video, let us see Newton's forward differentiation formula. That is, first formula is for dy by dx and second formula is for d square y by dx square. So these two formulas we are deriving it from the Newton's forward interpolation formula. So once you differentiate with respect to x and then by using u is equal to x minus x naught divided by h, we can get the formula for dy by dx. Similarly, once again if we differentiate it, we used to get d square y by dx square. Next is, and these two formulas dy by dx and d square y by dx square, both the formulas are in terms of u, where u denotes x minus x naught by h, and h is the interval length and x naught is the initial value. And then these two formulas can be reduced further by substituting x is equal to x naught. When you put x is equal to x naught in this u, x naught minus x naught will give you 0 and hence u is equal to 0. That's what, if we put x equal to x naught, then in the above formula we can substitute u is equal to 0, so that the first two formulas which is mentioned in terms of u has been reduced without u, that is u is equivalent to 0, so that these two formulas are reduced into dy by dx at x equal to x naught is given by 1 by h into delta y naught minus 1 by 2 into delta square y naught and etc. Similarly, d square y by dx square at x equal to x naught is equal to 1 by h square into delta square y naught minus delta cube y naught and so on. Okay, so if we remember these two formulas, that is the first formula and then the second formula, if we put u is equal to 0 in this, we will get the below two equations or two formulas, dy by dx and d square y by dx square. So these are the formula for Newton's forward differentiation. Next is Newton's backward differentiation formula. So this we are deriving it from Newton's backward interpolation formula. So first order derivative will give you dy by dx is equal to, here if you notice the formula are in terms of v, where v takes the value x minus xn by h. And similarly, once again if you differentiate, you will be getting the second order, that is d square y by dx square, which is also in terms of v. So from these two equations, we can reduce the formula still further by taking x is equal to xn. When you put x is equal to xn, then this v will become 0. So if you put v is equal to 0 in dy by dx and this d square y by dx square, we used to get these two formula, that is dy by dx at x equal to xn and d square y by dx square at x equal to xn. So when in the question, if they ask you the derivative, that is first order and the second order derivative at x equal to xn, means directly we can use these two formulas. If they ask you at some other value of x, means then we can go for this general formula in terms of v. Similarly for forward also. Now let us see the first question. Find the first two derivatives of x to the power 1 by 3 at x is equal to 50 and x is equal to 56 for the given data. So here the data is given for x and y, so that y is equal to x to the power 1 by 3 is the function. So we have to find out the first two derivatives of y. First two derivatives means we have to find out first order derivative and second order derivative. That is dy by dx and second order is d square y by dx square. So both we have to find out at the point x equal to 50 and x is equal to 56. So at x is equal to 50 and x is equal to 56. So if you see the data given here, 50 is the very first value, which means that this is x naught. Similarly, 56 is the last value, so we can consider it to be xn. So now we have to find out both dy by dx and d square y by dx square at x equal to x naught and x equal to xn. So here we want to know the formula for dy by dx at x equal to x naught, d square y by dx square at x equal to x naught, and then dy by dx at x equal to xn, and then dy by dx, that is d square y by dx square at x equal to xn. So totally 4 quantity we have to find out. So this is one formula, this is another formula, this is third formula, and then fourth one. So here first and second are forward difference formula, and third and fourth are backward difference formula, because x is equal to xn. 1 and 2 represents at x is equal to x naught. So for all these four terms we are having separate formula, so we can apply that formula. So before that, what we have to do here is we have to form the difference table. So now before going to the formula, first we have to form the difference table. So how to form the difference table is, here x value and y value are taken from the given problem. Next we have to find out the first order difference, that is delta y is nothing but the second value minus the first value, that is 3.7084 minus 3.684. So taking the difference of this, that is always second value minus the first value. So here it gives you 0.0244. Similarly we have to do for all the remaining values of y. Then again we have to find out delta square y, delta cube y. So here delta cube y takes the value of 0. No need to further find delta power 4y and so on. So this is the difference table, and here in this difference table the first value represents x naught, first value of y represents y naught, and this is delta y naught, and this is delta square y naught, and this is delta cube y naught. Similarly in the table all the last values should be considered as xn, yn, and then del yn, del square yn, and then del cube yn. So while going for the last value we have to use backward difference operator, so that here we are denoting it as del yn, del square yn, and del cube yn. So now we have to substitute these values in the formula directly to obtain the value. Let us start with Newton's forward differentiation formula, that is dy by dx at x equal to x naught is 1 by h into delta y naught minus 1 by 2 delta square y naught, and so on. So here what is h? H is equal to 1, that is from the given data the interval length of x is h, and here it is given as 1. So here we can consider h is equal to 1. Now we can directly substitute here in the formula, that is since h is equal to 1, 1 by 1 is 1 into delta y naught. We can take the value of delta y naught from the table, that is 0.0244. You can refer to the table value here, 1 by 2 into delta square y naught. What is delta square y naught? Is minus 0.0003 plus 1 by 3 into delta cube. Delta cube y naught is 0, and the higher powers also equal to 0. So now after simplification we will get the answer as 0.0246, right? So this is the answer for what? Dy by dx, that is first order derivative at x is equal to 50. X naught is 50 here. Similarly for second order derivative it is 1 by h square is 1 square, delta square y naught is minus 0.0003 is delta square y naught, minus delta cube y naught is 0, and for higher powers also it is 0. So we can omit that. So finally the answer is minus 0.0003. So this is the answer for d square y by dx square at x is equal to 50. So both the derivatives, that is first two derivatives we have obtained at x is equal to 50. Similarly we have to do it for backward differentiation formula. Now coming to backward differentiation, dy by dx at x equal to xn we want. Here also h takes the value 1 here. Del yn, del square yn are all the last value taken from the difference table. It is 0.0229 is del yn plus 1 by 2 into del square yn is minus 0.0003, and del cube yn is 0, and higher power also becoming 0. So finally, after simplification, we used to get the answer as 0.0228. Okay, and this is the value of what? Dy by dx, that is first order derivative at x is equal to 56. Similarly, for second order derivative, this is the formula. So here it is 1 by 1 square del square yn is minus 0.0003 is del square yn plus 0. Okay, del cube is 0 and del power 4 also 0. So this is equal to, directly the answer is minus 0.0003, and this is the answer for d square y by dx square at x equal to 56. So here the first two derivatives at x equal to 56 are given as 0.0228 and minus 0.0003. So this is the way we have to use numerical differentiation formula. Okay, so in this problem directly they have asked you to find the first two derivatives at both the endpoints, that is at x equal to x naught and at x is equal to xn. So there are direct formula we can use to obtain these values.